Hey everybody, and welcome to the Daily Space Weather Show. We've got coronal hole high-speed streams coming to Earth as we speak. You can expect those to only intensify. Also a little bit of sunspot growth and some other exciting stuff going on. We'll tell you all about it here at the Smash News Network, least busted name in news. This is the past 24 hours from SDO, the Solar Dynamics Observatory. An important feature to show here. And here's what I'm talking about. Around this massive coronal hole, there is a filament almost continuously surrounding it. You can see this dark absorption feature right here, stretching all the way around the coronal hole. An interesting feature indeed. Could see a massive coronal mass ejection. Of course, it would be unlikely for that entire filament to eject all at one time. So, but a great example there of a huge plasma filament. Once again, one of the largest we've covered. And you can expect all the excitement to only continue. And we've been forecasting it for months, an uptick in coronal holes for the next couple of years. Here's the northern hemisphere. You can see that filament hanging out there around the northern perimeter of that coronal hole. Also a crown prominence up there. There's a closer view for you. And by the way, thanks to our YouTube viewers, if you're new to the channel, don't forget to press the subscribe button. And if you're anything to the channel, press the like button. Yes, we need your help getting the content onto screens. So congratulations, folks. You found the world's most comprehensive daily space weather show and the most detailed solar imagery you'll find in the known universe. So press the like button. That's okay. We'll wait for you to do so. Press the share button. Leave us a comment. Even a mean one. You're invited to try to hurt my feelings. We find it cute. And I would have to say again, folks, press the like button, lest thy soul be cast into an ever-deepening and darkening abyss of pseudoscience, nonsense, garbage, crap, and bugged-out, nonsensical content on YouTube. Press the like button. Do it. Do it right now. Pause the video. Unless you're watching the live premiere, of course, then by all means don't pause the video because press the like button or we will find you and we will shame you. Today's featured product is, by the way, these are paid advertisements. Today's featured product is the fictional cosmic structure, the galactic current sheet. More advanced trolling going on right here. Now, unfortunately, we don't have the galactic current sheet in sheet form. However, we do have it in comforter, duvet cover, poster, tapestry, canvas print, mini skirt, and more. The galactic current sheet. It doesn't really exist, but celebrate the apocalypse in style. Curl up in the bunker with your galactic current sheet throw blanket and delay the cannibalization of you by your bunker mates by a few hours, perhaps by telling them ridiculous stories about how it must be the galaxy that's caused your current conundrum. The Galactic Current Sheet, fictional cosmic structure, today's featured product, and our first paid endorsement of the day, as we attempt to create a sustainable channel here and offset some of our massive operating losses. Another paid endorsement is the Hemp Lucid Shop. The most popular products are the CBD tinctures. However, gaining in popularity are mushroom gummies. And massive savings available here on sleep, stress, and immune stacks. Look at that, $15 and over $70 on the full stack pack. So check those out via our link below the video, right there conveniently in the description. We wouldn't want you to have to type in a URL or anything. No. Or visit our homepage. I know that's a lot of work. So click the description. Check out the Hemp Lucid Shop if you're in the market for some of those products. Shop via our shop and help out the channel that way. Or perhaps help out your own health via shopping at our Amazon shop. It's amazon.com/shop/Smash-O-Mash. Today's featured product over there. And save 41%, folks, on zinc. I won't make any medical claims about it, but it's apparently a pretty important mineral. Yeah, it's an important mineral. Make sure you eat the right rocks by picking up some of the zinc from our Amazon shop. So that's another paid endorsement for the channel. Amazon.com/shop/Smash-O-Mash if you want to see what I take. There you go. There are some of the supplements that I've been known to consume on the regs. Another way to support the channel, the best way of all, is via becoming a member of the Smash Team. Smashomash.com/Smash Team. The bronze level is $0 per month. The silver level is $2.99 a month. The gold level is $9.99 a month. The best value is the gold annual paid-up subscription, as it includes complimentary merch. So check it out. Additional content available there. Smashomash.com/Smash Team. We built our own because it's the way to go, folks. Have your own website if you want to create a brand. I mean, what can I say? Additional content is available there. We are also on Patreon. There are even YouTube memberships. The main additional content is at smashomash.com/Smash Team. So we built a massive web ring to benefit people just like you. Starting back in 2018, when a crack YouTube unit was sent to social media prison for a crime we didn't commit, we promptly escaped the maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. You certainly can. Right there's a link to it. There's also a link right there to it. And you can also find links to the Patreon, PayPal, Spotify, Hemp Lucid, Amazon, Redbubble, even a permanent invite link to the Discord channel. So visit our massive web ring. It was built for people just like you. And it was built to basically slap the face of censorship. So, yeah. I mean, hey, what can I say, folks? You build your own website, you make your own rules. Although, keep in mind also, you create your own liability. So anyway, here is October 27th and October 28th to date in SDO intensitygram. And you see a little bit of sunspot growth happening once again there in the northeastern limb. This sunspot here finally got named after dissipating and reforming over the past 4 or 5 days. It's finally called 3472. I don't know, I guess that was a forecast, but it's now got a name. And besides that, not a lot of activity. Most of the activity is in the northeast. And if you're expecting a forecast for where to see more space weather happening, expect more things to be happening soon in the northeast. We'll tell you why here in a minute. Give us a few minutes, as there's plenty of other stuff to cover. There's the SDO magnetogram for the same time period, October 27th and October 28th to date. Moving right along, and we've put up a 48-hour video here in 131 angstroms because of this massive solar flare you just saw up there in the northeastern limb. So we had to cover that, as we missed yesterday because there was a bit of a crisis going on here at the Smash News Network. So we had to sort of mitigate that disaster. And it happened just before midnight on October 26th. So just before October 27th, at about 2300, an M-class flare, the first M-class flare in quite some time. I believe pushing 2 weeks, maybe over 2 weeks, actually. So there's that M-class flare one more time. That's a 48-hour video from SDO. We also put up a 48-hour short. We'll show you that here a little bit later in the video. So check it out. There's some ground deformation happening on Iceland. So a significant amount also. That's only over about 2 days there. Seeing 3 centimeters of uplift happening. Not necessarily expecting an impending eruption right now. However, magma is getting closer to the surface. So lots of volcanic information coming out about Iceland. Here's the volcanic rundown for the whole planet. There's a great view of Etna's lava fountaining activity, Strombolian activity indeed, from Mount Etna. Yes. So Etna back on the list. Brennisteinsfjall on the Reykjanes Peninsula. Ground deformation happening there. Seismic activity has been dropping over the past 24 hours. So, in any case, some magma moving closer to the surface there. Some rock fracturing happening under Fagradalsfjall. Seismic swarm has been going on for a few days. Again, it has been decreasing. So, several Iceland volcanoes there showing up on the list. I'm not going to try to pronounce them all because those are really hard to pronounce. They're not really erupting at the moment, just having some magma moving around beneath them. So eruption could be coming soon, but not really impending at the moment. Kluchevskoye is exploding, however, and producing a 22,000-foot plume of volcanic ash. Please do not pole vault the Kamchatkan caldera of Kluchevskoye. Unknown volcanic ash cloud from Mount Mayon. Dakono exploding. 7,000-foot ash plume from Dakono. Popocatépetl exploding in central Mexico. Flight level 190. Flight level 160 in Guatemala from Fuego. Flight level 190 from Nevado de Ruiz in Colombia. Ecuador features Revenador exploding. Flight level 150 as a 15,000-foot ash plume, and a 22,000-foot ash plume emanates from Sabancaya's caldera as it explodes in Peru. Moving on to earthquakes. We've got a lot of earthquakes around the Pacific Rim for the past 24 hours. And we are getting a little bit overdue for a 7 magnitude quake here. Past 90 days have been a little bit light on the 7 magnitude earthquake. So anyway, there's the past 90 days. Here are the past 24 hours. We'll cite quakes of a 5 or greater magnitude. Several happening in the U.S. Just not of a 5 or greater magnitude. So that's USGS's 24-hour map. The first on our list of 5 and larger magnitude quakes was in northwestern Canada, a 5.1 at 3:01 this morning. Then, only about 43 minutes later, a 5.3 right in the same location. So a perfect example of a foreshock right there. Remember, folks, any earthquake can be a foreshock. And again, we are seeing a lot of quakes around the Pacific Rim here, so it could be about time to see a large quake somewhere, possibly one that produces a tsunami. This 5.5 didn't produce a tsunami near Tonga. It was at over 200 kilometers estimated depth. It occurred at 4:33 this morning. So there's the largest on the list so far. Then Solomon Islands had a 5.5 also. 5:31 this morning for that 5.5. Quite a ways to the west of the Tongan quake. Here one coming in as we create the video. It was smaller than a 5 magnitude, so we're not going to report it. Marianas Trench region had a 5.3. That was at over 100 kilometers depth at 8:08 this morning. Vanuatu had a 5.6. That was at 9:55 this morning on October 28th. That was also at depth over 200 kilometers estimated depth. Timor-Leste had a 5.5 near the surface at a 10-kilometer depth. Indonesia had a 5.4 at 15:01 Universal Time this afternoon. Afghanistan had a 5.1. Suboptimal near the town of Herat once again, possibly doing some further damage. Although they have had a series of 6 magnitude quakes in that area. That's where our list ends. And we go back to space. So here we've put together the SDO 304 plus 171 angstroms. Large crown prominence still hanging out down here at the South Polar region. It's a crown prominence, as it were. And here we've dropped the 304 angstroms for the house favorite alone, the SDO 171 angstroms wavelength. They're all 24-hour videos. Here's a little closer view of that massive coronal hole. And here we've swapped out the 171 angstroms for 211 plus 304 angstroms. Once again, note that filament that's practically encircling the entire coronal hole. So an interesting feature indeed. And by the way, we are expecting an uptick in the solar wind in the coming day or two. So we're seeing indications that we're going to see a significant uptick in the solar wind, and it's already at over 500 kilometers per second. The 10.7 centimeter radio flux, now up to 128 solar flux units. So a modest increase in the radio flux here. There's the 1-year graph depicted by this black line right here. 128, the new radio flux number, sometimes referred to as the F107. Sunspot number and radio flux are directly proportional, meaning higher highs for the radio flux means higher highs in the sunspot number. And of course, you can see how proportional that is to the red line there. Radio flux and sunspot number, closely related to solar cycle progression. So NOAA's forecasting some geomagnetic storms Sunday night into Monday morning, folks. Sunday night into Monday morning, expecting some further increases in the solar wind. We might even see that earlier than that, because we are seeing an indication of coronal hole high-speed stream additional density waves coming in here a little bit early, which does happen. So coronal hole high-speed streams sometimes show up late and they sometimes show up early. We'll tell you why here in a minute, but that's NOAA's forecast. Late tomorrow night into early Monday morning, we could see some additional geomagnetic fireworks. Next, the last 4 hours of Earth's magnetic moment from space. And like I said, we do have a high-speed coronal hole wind stream. We're expecting a further intensification of that in the coming 24 hours. So this depicts magnetohydrodynamic pressure for the past 4 hours. The units of magnetohydrodynamic pressure are known as nanopascals. As a high-speed coronal hole wind stream continues. So we are seeing some auroral imagery get shared over on Twitter. Here's the North American ground magnetic perturbations map. There might be some aurora visible, mainly at higher latitudes tonight, not so much at mid-latitudes. This is pretty mild. We did see a brief period of geomagnetic unrest. Let's take a look at the whole Earth map next. There's the full globe view. So that's once again the past 4 hours. It depicts magnetic flux density, change in Earth's B field, or geospace delta B. The units of magnetic flux density being nanotesla. This will indeed show you the likely places to see the aurora, so it could be helpful in letting you know whether you ought to go out and try to see some. Remember, folks, if you do see the aurora, make sure you break out your camera. Take video, take photos. The aurora are largely ultraviolet light, which is not visible to the naked eye. Only a small portion of the aurora is visible light, so make sure you use your camera because you can't see ultraviolet light. It is outside the visible spectrum. It is a higher energy and a smaller wave, a higher frequency wave than visible light. So there's this brief period of geomagnetic unrest. KP 4.33 did occur. Now we're back down to a KP3. The average of global geomagnetism, planetary K index, KP3 is the current situation. And looking at the Lagrangian 1-point space weather station, the ACE spacecraft. Again, we are seeing high-speed solar winds at the moment here, about 520 kilometers per second, although quite diffuse at the ACE and a lot denser at the Discover. So check it out. The Discover is showing 16.14 protons per cubic centimeter. See, that's the Discover. Once again, here's the ACE. So a prime example of how filamentary the solar wind is. Those two spacecraft both at Lagrangian point 1, the one detecting 2.5 protons per cubic centimeter, the Discover detecting 16 protons per cubic centimeter. So again, we are expecting another uptick in the solar wind velocity in the coming 24 hours. You can expect to see the density dip at the Discover as well. So current conditions are about 16 protons per cubic centimeter for the solar wind density, solar wind velocity about 520 kilometers per second. There are your GOES magnetometers. Now, they are located at the outer portion of the outer Van Allen belt. They orbit at about 23,500 miles of altitude. They are geosynchronous near equatorial orbits, and it's just about noontime local time for the GOES 18, depicted by the blue line and the blue N there. That means noon local time for the satellite. And you can expect to see some pretty wild gyrations in this in the coming days, as there are likely geomagnetic storms. We're expecting quite a significant coronal hole high-speed stream, and you can expect more coronal hole high-speed streams to continue for the next approximately 2 years. Continuing right along to our top view ecliptic plane field plot, and this is why we think there may be some sunspot growth, formation, or rising in the northeast. So you see that rapidly accelerating South Pole current sheet? Look at this red area right here. This is South Pole magnetism there in the plasma, and it is rapidly heading toward Earth. So sector boundary crossing will likely be here by tomorrow when we make tomorrow's daily space weather video. And let us know in the comment if you like the new time slot. 7 p.m., the new time slot for the daily space weather. It's almost the same, folks, except we get to show the visible satellite every day when we do our meteorology segment instead of the shortwave radiation map, because it's going to be light out. It's just awesome. Anyway, here's our line of sight field plot, and you'll see a lot of motions happening over there in the east. That is the magnetic indecision happening over there. And before we get to coronal holes, let's look at the line of sight ecliptic plane field plot. So, eyes on this area right over here, you'll see a waving around of the polarity there. We've got South Pole oriented coronal holes here emerging. So, yes, the possibility of more sunspots either rising, growing, or forming in the northeast, that's called forecasting, understanding the physics and the correlation of the data. Line of sight ecliptic plane field plot, one of our latest additions to the channel. So here's our line of sight coronal hole plot. We'll let that play through twice, and then we will pause on the last image before we show the SDO imagery. So there you go. The coronal holes that are set to send some serious space weather our way in the coming 24 hours are North Pole oriented. We've got a series of South Pole oriented coronal holes rotating in. So right here you've got north. This one down here's north, and all over here these are all south. So the sector boundary crossing is like right there. And again, by tomorrow's daily space weather video, the Earth is likely to have crossed that sector boundary crossing into the south magnetic polar region. So that's what's going on. How about a closer view? Since coronal holes are going to be the story here for a couple of days, there you go. There's a spectacular view in SDO 211 angstroms. That species of ionized iron does not like to be in coronal holes. So, I mean, that's what you're seeing there. You're seeing a shortage of that species of ionized iron. For whatever reason, it doesn't like to be in that area. So 211 angstroms is the optimal wavelength to view coronal holes. Some other wavelengths work well. 211 works the best. And let's move on to sunspots. And please stop referring to me as a gaping gash. Sunspots. They did come up above 50, exactly as forecast. However, now they're dropping back down toward 50. I suspect they're going to move up again a little bit before tomorrow, maybe not back over 60 again. Sunspot number currently around 53 or 54, according to the Royal Observatory of Belgium, rather. And next are flare probability and scoreboard. So there's that sunspot that we were talking about for days. It grew, it shrunk, it grew, it shrunk, it grew, it shrunk, and now it finally got a name. 3472. So that's good. I think there might be like 2 or 3 more groups likely to get names in the coming 24 hours. And let's show that next. There's SDO AIA 94 angstroms and SDO HMI continuum. The 94 shows you the highlighted active regions. That's another species of ionized iron's extreme ultraviolet emissions. And let's cut out the 94 angstroms to show just the continuum. So yeah, we've got some significant growth down here. That's a lot of new umbre there. So we might be going back over 60 sunspots here in the next 24 hours. Also a bunch of new umbre forming up here. A little bit of growth over here. And there's a sunspot down here also in the southwest. So right in there. Right in there one formed. It's at a pretty high latitude also. And there may be some sunspots forming in here as well. So I would say the most likely place to see major growth though is up in these northeastern areas. So that's the forecast for sunspots. And let's move on to energetic particles and flares. No spikes in the proton flux, but there is certainly a higher and higher likelihood of a spike in the proton flux. You're more likely to see a solar energetic particle event during a coronal hole high-speed wind stream. So don't be surprised to see a spike in that, especially if you see a large solar flare. So proton flux remains flatlined. It might not be for long. The X-ray flux here still below a C-class level. It's about a B5, actually, at the moment. Expecting an uptick in this because, again, quite a lot of new sunspots have formed in the past 24 hours. So a lot of new umbre should be counted by the time we do tomorrow's video. We'll see what happens. Let's take a look at the SDO. Here's 94 plus 131 angstroms. And since none of those are occurring at the polar regions, flares don't really happen at the polar regions. There's the equatorial zoom for the past 24 hours. Most likely place to see large flares remains in the northeastern limb, above the Earth scale. Also, before we continue on, we did make a short, and it's a 48-hour SDO 94 angstroms video because we wanted to include that M-class flare. So if you want to check that out, it's youtube.com/smashomash/shorts. Again, that flare occurred just before midnight on October 26th. And wait for it, and there it goes. You could actually see the plasma motions happening before that. Exciting stuff there. And let's take a look at a star chart. The sun just peeking below the horizon here over Lehigh Valley, Pennsylvania. If you're viewing the dusk sky, you might see the moon rising. Saturn up high on the ecliptic. And we're only 1 day from full moon, so the moon will be rising around 8 p.m. Eastern Time tomorrow. And next, a solar system forecast. There's where things are today. There's where things will be tomorrow. There's where things will be in 1 week on November 4th. So moving right along to our astronomy photo of the day. And this one is known as Gamma Cassiopeiae. So that bright blue star is affecting this ghostly nebula. So as we pan down here, panning down. Now that's about 4 light years away. However, the ultraviolet light from that star is affecting those clouds of mostly hydrogen gas. As recombination happens there, you can see some Some bluish color there. That is the actual light reflected from the star off the dusty portions of that nebulous cloud. Let us know in the comments if you think it looks like a series of spooky, spooky ghosts. So a great example of how a star 4 light years away can affect a nebulous cloud. Pretty sweet. apod.nasa.gov if you want to check it out yourself. Gamma Cassiopeiae showing up there on the NASA site. Next, it's time to get to coronal mass ejections, and there have been some. Are they earthly directed, you ask? Well, we'll tell after we do some analysis. So I wait to do my analysis until I create the video. So that's yesterday's CMEs, 114 frames from October 27th. Here are an additional 68 frames from today, October 28th, and there was a CME that just occurred there. Just seeing it come out of the lower left, the southeastern limb, right there at the end. And we'll take a closer look at that here in a moment. First, we'll add the Soho-Lasco C3. And there you can see that CME. Let's get a little bit closer. So that coronal mass ejection started to emerge from behind the coronagraph around noontime today. And if you're wondering if it has an earthly directed component, so am I. Let's take a look at stereo A next, which is located right here where my pointer is. As it gains on Earth, it gains us better perspective on the trajectory of coronal mass ejections. So here we go, the raw imagery on the left, the difference imagery on the right. We have the imagery on the left a little bit ahead of the difference imagery. And so far as I can tell, that coronal mass ejection is not likely to have earthly directed components. We expect that to miss Earth to the southeast. So, however, if that's not enough information for you, let's take a look at even more our custom coronagraphs. Here's a 24-hour video with SDO 193 angstroms, synchronized with the Lasco C3 in blue and C2 in red. So I'm not seeing plasma motions when that happens, are you? Let us know in the comments if you disagree. I believe that is behind the southeastern limb, where that's coming from. I don't really see any action on the Earth side as that occurs. Here we've dropped the Lasco C3 and added 304 angstroms to the SDO imagery to add even more contrast. And I don't see a filament eruption there or limb darkening or anything resembling action. So not only not earthly directed, but probably somewhat the opposite direction from Earth. Again, let us know if you disagree. We don't mind. And let's talk filaments next. And let's cut back to where we started. Look at the size of that filament that is encircling that coronal hole. That is one berserk filament. Anyway, moving right along to our view from Big Bear. There you go. There's Big Bear's hydrogen alpha imagery. And that filament, interestingly, that's actually the Eric Schmidt filament. This one down here is the Larry Page. Down here is the Sundar Pichai filament, which is shrinking. This one over here, this is the Mark Zuckerberg. This is the Neil Diamond. And this one up here, I don't remember if I named that one or not. Did I name that one the Tim Cook? I forget. Anyway, if you want to name filaments after living people, join us over on Twitter, otherwise known as x.com, x.com/smashomash. It's easy to name filaments. Just pick a filament. Let's say, I don't know, this one down here. There you go. Pick a filament, take a screenshot, head to X, delete your Epic Pen nonsense, type in the hashtag, name that filament, and then paste your screenshot, and there you go. Name that filament after living humans. Not this one. Living humans. x.com/smashomash. Here's more from Big Bear. We've got some significant prominences, not the least of which is this crown prominence. Prominence over here. Prominence setting in the west as well. So lots of filaments both on and off the Earth-facing portion of the solar disk. Let's move to bonus features. Crown prominence at both poles. As we get closer and closer to solar maximum. And no, we are not yet at solar maximum. Oh, yeah. I don't care who tells you that we are at solar maximum. I mean, they were telling you you're at solar maximum in January of this year. How did that work out? How did that work out when the sunspot number then went to 200 plus? Seems a little inaccurate. Seems like it might be, I don't know, misinformation? Or is it disinformation? Or is it just shart lighting? Pathetic shart lighting continues. Bonus features are next. Satellite charging hazards. There are some over India. Some significant surface charging hazards there could cause some minor communications breakdowns for a brief period there. As electrons build up on the outside of spacecraft, that's what surface charging hazards are. Things like the GOES 16 or GOES 18 could experience some communications breakdowns as a result of that. Sometimes it can cause missing data. Anyway, here's the GOES electron flux for the past 3 days. And kind of low levels here. I don't know what the forecast is like, but there's the 1-year graph. Some rapid variations there in the electron flux going from moderate to low levels and back to moderate levels. There's the NOAA forecast depicted by the green boxes. And I would tend to think that we're going to have a big downtick by tomorrow night into Monday morning. Next, the ionosphere itself. We're going to show one slice of the ionosphere. The F layer, which is located about 300 kilometers of altitude. Here it is in its vibrational frequency. And we are seeing a bit of action happening up there, having seen geomagnetic unrest conditions, following some geomagnetic storm conditions and some more to come. So some significant scintillation happening there in the ionosphere. It doesn't only puff up, it gets bigger in its entirety. It gets lower altitude and higher altitude all at once. So that is the ionosphere in megahertz. And when I show the anomalygram, you'll see a lot of low-frequency anomalies. So there it is. The anomaly in megahertz from a 30-day median, and you will see a lot of red showing up on that. Also some rapid swings there. And it's doing a great job of highlighting the South Atlantic anomaly right over the South American continent. You can see those rapid variations there. A huge persistent dip in the ionosphere in that location, Earth's weakest point in its magnetosphere. Anyway, here's the latest image, 22:15 universal time for the ionogram. And there is the anomalygram. A lot of low-frequency anomalies happening here over the South Pacific. Next, the whole atmosphere model, or WAM, as we transition from the ionosphere to total electron content. So that should help out all of you GPS and radio users out there. Shout out to our viewers who use equipment requiring space. Space, it's only going to get more and more important as time goes on. We didn't just accidentally leverage ourselves here. We didn't chase the bandwagon about space weather. I almost majored in cosmology in the mid-1990s. Next total electron content forecast. It's free electrons to about this level, 12,500 miles of altitude, down to your GPS handset. It's literally a count of free electrons. And I still don't like this map. It looks erroneous. I should send an email and ask them what's going on with it. That does not look at all correct. However, this one looks just fine, so we'll show the North American anomaly. And lots of high electron counts over North America here. Big time high electron counts over a consistently large portion of the entire continent. All the way from Mexico to northern Canada. I'll let it play through one more time since it's showing significant anomaly from the 10-day average. So quite a lot of electrons there showing up over North America. And we'll close out space weather with the latest high-res imagery. So let's see. Up here in the northeast, that sunspot's grown since we did show prep. That sunspot's got more umbre than it did 12 hours ago, that's for sure. I thought I saw... Oh, there's another new sunspot. I don't know if that one's named or not, but that's a beta gamma class, most likely. What else do we have? Anything else? I don't know. Let us know in the comments what you think. And it's time to get to meteorology. So the big story over the U.S. is all kinds of crazy weather showing up in the central part of the country. Let's break it down as to why. Massive pressure gradients have formed. So check it out. You've got, this is mean sea level pressure and surface winds. You've got low pressure right in here, which is pulling air toward it. You've got high pressure up here, which is pushing air away from it. And you've got a collision happening there with a huge pressure gradient. That's the kind of thing that causes bomb cyclones, as they're called. And rapid precipitation, sometimes in the form of snow, are the result of that. There's ice coming to Texas. So there's a prime example of massive pressure gradients forming as a low meets a high. Anyway, here are the surface winds of the east. These are the jet streams of the east. Jet streams of the central world shown here. Surface winds of the central world shown here. A strong low off the west coast of Ireland has shown up. Surface winds of the west, the Americas. And these are the jet streams. A huge bend in the jet stream as it makes a 90-degree turn from south to east over Montana. So there's also a jet stream convergence happening here just west of the Great Lakes. That's what's up from a global perspective. And as we zoom in closer and closer to the lower 48, there are the visible satellite images. Pretty freaking sweet, right? Love the visible satellite. And here's a close-up of the Oklahoma Panhandle. Since weather is descending in that direction, I figured I'd show a zoom. Just awesome. Oh, and you see all these areas with clouds that are aligned with each other? See all those parallel herringbone style clouds? That's not HARP. HARP affects the ionosphere, not weather. Weather is hundreds of kilometers below the below the ionosphere, so there's that. That's caused by a pressure gradient as those lines of clouds attempt to reach static equilibrium. Clouds form when high pressure meets low pressure. See, I set that one up with the nullschool.net imagery, because that's where you find everybody pointing at the sky and blaming mankind for creating clouds. Mankind does create clouds. That is true. However, HARP has nothing to do with the weather. Continuing right along to precipitation type. So there's where the snow and rain are falling. Let's sort of focus on this area there. So there you can see the snow-rain lines at the moment. Here's our current snow depth, and it's going to be changing. There's where the next 3 days will be. Let's go to the next 12 hours. There's the next 24 hours of snow depth. New snow, rather. And there's the next 3 days. That's the Euro model, by the way. Here's the GFS model, showing it more concentrated on Colorado. So it looks like the hot air is not preventing all of that snow from falling. That's a lot of hot air being dampened by a lot of the white stuff. So here is the weather.gov map. If your location's lit, click it. Is that massive flooding on Hawaii? Wow, look at the Hawaiian floods. Dag, coastal flood statements all around. Could cause some volcanic upticks, folks. Although those volcanoes are really not known for phreatic eruptions. So anyway, there's your weather.gov map and lots of cold weather type warnings on there. And let's break out some forecasts. First, that is the GFS 72-hour pressure and precipitation forecast. Significant icing coming to the Texas stovepipe and across Oklahoma. Also flooding. And you can see look how tightly bound these pressure lines are. Those pressure lines right there over southern Colorado. That's going to create huge winds as the atmosphere attempts to reach static equilibrium. It's not because of chemtrails, it's not because of contrails, it's not because of geoengineering, it's not because of cloud seeding, it's because of pressure gradients in the atmosphere. Here's your GFS 72-hour accumulated snow depth change forecast. And look at all the snow that's expected to hit Texas. Also, Oklahoma will be mostly blanketed. It's only going to be like an inch, but nonetheless. That's a GFS 72-hour positive accumulated snow depth change forecast in inches. Ta-da! Here's the total accumulated precipitation forecast in inches, and look at that. Arkansas is going to get kaplastered. Also, southeastern Missouri and western Kentucky and Tennessee. All expecting like 4 inches of rain. So pay attention to that. Next, the jet stream forecast. As that cold air makes its way to the east, more Canadian air descending down into the U.S., bringing cold temperatures, shown here in the GFS 72-hour temperature anomaly forecast in degrees Celsius. So most of that cold is going to sort of stay to the west of the mid-Atlantic states. Texas is expecting temperatures like 20 degrees Celsius below normal there. Also, Montana expecting like 25 degrees Celsius below normal. Also, North Dakota, going to be very cold for this time of year. And early winter showing up there in the north central U.S. Dag! Next, lightning. And we've zoomed out to show all the lightning in Central America and South America, but we're going to zoom back in here. So we do have some lightning across the U.S. There we go. Texas, the current lightning capital of the U.S. And let's check a real-time map. What was striking while we made the video? Kansas. Fairly mild as far as lightning activity, which will continue to subside over the next couple of months as winter approaches. We'll close out the video with Doppler. The visible satellite. Just gorgeous. And there is the water vapor map. The water vapor map will also show you some of those pressure gradients where you see dry air right next to moist air. That has to be a pressure gradient, because pressure, temperature, and humidity are all functions of each other. Here's your recap: U.S. Doppler radar. Visible satellite. My personal favorite of the NASA GOES Interactive Weather Satellite Suite. And the water vapor map, which, if you understand atmospheric physics, you can forecast your weather by using the water vapor map. Impress your friends and foes. By doing so, tell them about space weather before it shows up, and just be a weather guru, folks. I mean, we empower our viewers to do this. We don't try to gaslight our viewers and feed them a line of utter nonsense. So, anyway, we'll see you soon. Congratulations on realizing the channel exists. Don't forget to press the like button. Otherwise, your soul will be cast into an ever-deepening and darkening abyss of bad horror B movies and pseudoscientists raining down nonsense on you. In the meantime, may that solar wind be at your back. I'm going back to the bunker. I'm going back to the bunker again. I heard a bird, encouraged me to climb in.